projects. In this video, we are going to explain about the project title Development of an Interpretable Maritime Accident Prediction System using Machine Learning Techniques. Introduction. The project aims to develop a transparent and understandable maritime accident prediction system using machine learning techniques. The goal is to create a system that not only accurately predicts maritime accidents but also allows stakeholders to interpret the underlying factors contributing to these accidents. Maritime accidents have significant consequences, causing severe damage to both human lives and maritime assets such as vessels. Despite their impact, existing approaches to analyzing maritime accidents often lack practicality as they fail to consider the holistic nature of these incidents. The proposed system addresses these limitations by conducting comprehensive ex post analyses of maritime accidents and providing actionable accident prevention strategies. By taking a more holistic approach, the system aims to improve the practicability and effectiveness of accident prevention measures in the maritime industry. To achieve its objectives, the project employs various machine learning algorithms. These algorithms are used for tasks such as variable selection, data retrieval, hotspot identification, and constructing predictive models for maritime accidents. By leveraging machine learning, the system can effectively analyze large data sets and identify complex patterns associated with maritime accidents. Objective of the project The objective of the project is to create a transparent maritime accident prediction system using machine learning. This system intends to enhance safety measures within the maritime industry by accurately forecasting accidents, thus enabling proactive risk management strategies. Various machine learning algorithms like random forest, support vector machine, logistic regression, gradient boosting, and neural networks will be employed in the project. These algorithms contribute to accurate accident prediction by analyzing historical data and identifying patterns indicative of potential accidents. The project focuses on predicting different types of maritime accidents, including ship collisions, groundings, and oil spills. By predicting specific accident types, tailored preventive measures can be implemented to mitigate the risk associated with each type of accident. The performance of the machine learning algorithms is evaluated using metrics such as accuracy, precision, recall, and FN score. This comparison helps to identify the most reliable prediction models, allowing stakeholders to select the most effective algorithm for accident prediction. The project aims to provide valuable insights to stakeholders such as ship operators, port authorities, regulators, and insurers. By leveraging the predictive system, these stakeholders can improve safety standards, reduce accident rates, and minimize environmental impact in the maritime sector. Overall, the project seeks to enhance safety measures and promote sustainability within the maritime industry through data driven approaches. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of 5.5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing libraries. This module involves importing necessary libraries and packages required for the project. These libraries include popular Python libraries such as Pandas for data manipulation, NumPy for numerical operations, Matplotlib and Seaborn for data visualization, as well as machine learning libraries such as scikit-learn, TensorFlow or PyTorch for building and training models. Importing dataset. In this module, the dataset relevant to the project is imported into the environment. This dataset contains historical data related to maritime accidents, including features such as accident type, location, vessel information, environmental conditions, and outcomes. The dataset is usually stored in a structured format like CSV or Excel. Exploratory data analysis. EDA involves exploring and analyzing the dataset to gain insights into its structure, patterns, and relationships between variables. This includes tasks such as summarizing statistics, identifying missing values, visualizing distributions, and exploring correlations between features. EDA helps in understanding the data better and informing subsequent data processing steps. Data processing. This module involves pre-processing the raw dataset to prepare it for model training. Common data processing tasks include handling missing values, encoding categorical variables, scaling numerical features, and splitting the dataset into training and testing sets. Data processing ensures that the data is in a suitable format for input into machine learning algorithms. Data visualization. Data visualization involves creating visual representations of the data to communicate insights effectively. This includes various types of plots such as histograms, scatter plots, heat maps, and bar charts to visualize distributions, relationships, and trends in the data. Data visualization aids in understanding patterns and making informed decisions during model building and interpretation. Training and building the model. In this module, machine learning models are trained using the processed dataset. Different algorithms such as random forest, support vector machine, logistic regression, or neural networks are trained and evaluated to identify the best performing model for predicting maritime accidents. Model training involves fitting the algorithm to the training data and tuning hyperparameters for optimal performance. Performance comparison. After training the models, their performance is compared using evaluation metrics such as accuracy, precision recall, and F1 score. This comparison helps in selecting the most reliable model for deployment. Cross validation techniques are also used to ensure the robustness of the model's performance. Flask framework with SQLite for sign up and sign in. This module involves setting up a web application using the Flask framework and integrating a SQLite database for user authentication and management. Users can sign up for an account, sign in securely, and manage their profiles. Flask is a lightweight web framework in Python, while SQLite is a relational database management system used for small scale web applications. User gives input, and the given input is pre processed for prediction. When a user provides input through the front-end interface, the given input is pre-processed to ensure compatibility with the trained model. This involves applying the same pre-processing steps used during model training to transform the input data into the appropriate format for prediction. Trained model is used for prediction. The pre-processed user input is then fed into the trained machine learning model to make predictions. The model predicts the likelihood or outcome of a maritime accident based on the provided input features. Final outcome is displayed through front end. Finally, the predicted outcome or result is displayed to the user through the front end interface. This includes displaying the predicted accident type. The front end provides an intuitive user interface for interacting with the predictive system and interpreting the results. Algorithms used to implement this project, we have designed the following algorithms. The first algorithm is logistic regression. Logistic regression is a statistical method used for binary classification tasks where the target variable has two possible outcomes. It models the probability that a given input belongs to a particular class. In the context of maritime accident prediction, logistic regression is utilized to model the probability of an accident occurring based on various features such as weather conditions, vessel type, traffic density, etc. It's interpretable and can provide insights into which features are most influential in predicting accidents. Coming to the next algorithm, which is decision tree. A decision tree is a tree like model where an internal node represents a feature, the branches represent the decision rules, and each leaf node represents the outcome. It's a popular algorithm for both classification and regression tasks. Decision tree is used to identify key factors leading to maritime accidents. By constructing decision trees, it's possible to understand the sequence of decisions and variables that contribute to predicting accidents. SVM, support vector machine. Support vector machine is a supervised learning algorithm used for classification and regression tasks. It finds the hyperplane that best separates different classes in the feature space. SVM is applied to maritime accident prediction by finding the optimal boundary between accident and non accident instances in the feature space. It's particularly useful when dealing with complex data distributions and high dimensional feature spaces. Bagging classifier. Bagging, short for bootstrap aggregating, is an ensemble learning technique where multiple models are trained on different subsets of the training data and their predictions are aggregated to make a final prediction. Bagging is applied to improve the accuracy and robustness of the accident prediction system. By training multiple classifiers on different subsets of the data, bagging can reduce overfitting and improve generalization performance. Coming to the next algorithm, which is ADA boost. ADA boost, adaptive boosting, is another ensemble learning method where weak learners are trained sequentially, with each subsequent learner focusing on the examples that were misclassified by the previous ones. ADA boost is used to sequentially improve the prediction accuracy of the maritime accident prediction system. By combining multiple weak learners, ADA boost can create a strong learner capable of accurately predicting accidents. Coming to the next algorithm, which is voting classifier. A voting classifier combines multiple individual models and combines the predictions through voting, either soft or hard, to make a final prediction. In the context of maritime accident prediction, a voting classifier combines the predictions of multiple individual models, ADA boost, decision tree, and bagging classifier to make a consensual prediction. This leads to improved performance and robustness. KNN, K nearest neighbor. KNN is a simple yet powerful supervised learning algorithm used for classification and regression tasks. It works by finding the k nearest data points in the feature space to a given query point and then predicts the label or value based on the majority class or average of the k neighbors. In the context of maritime accident prediction, KNN is employed to identify similar instances of accidents based on various features such as vessel type, weather conditions, locations, and more. It's particularly useful when the underlying data distribution is not known and when instances of similar accidents tend to cluster together in the feature space. XGBoost, extreme gradient boosting. XGBoost is a powerful ensemble learning algorithm that belongs to the gradient boosting family. It's highly efficient and scalable, utilizing a combination of decision trees, has weak learners, and an optimized implementation of gradient boosting techniques. XGBoost is applied to maritime accident prediction to create a robust and accurate predictive model. It's known for its superior performance in handling structured data, dealing with missing values, and providing feature importance analysis. XGBoost can effectively capture complex relationships between features and the target variable, leading to improved prediction accuracy. Coming to the next algorithm, which is gradient boosting. Gradient boosting is an machine learning technique for regression and classification problems, which builds a model in a stage wise manner. It sequentially adds weak learners to an ensemble, each one correcting the errors of its predecessors. Similar to XGBoost, gradient boosting is used to develop predictive models for maritime accident prediction. It's effective in handling large data sets, capturing complex interactions between features, and producing accurate predictions. By iteratively improving the model's performance, gradient boosting can lead to highly accurate predictions of maritime accidents. Random forest. Random forest is an ensemble learning method that constructs a multitude of decision trees during training and outputs the class, that is, the mode of the classes or mean prediction of the individual trees. Random forest is employed in maritime accident prediction by building an ensemble of decision trees based on various features such as vessel characteristics, environmental conditions, and historical accident data. It's known for its robustness against overfitting, scalability, and ability to handle high dimensional data. Random forests can provide insights into feature importance and interactions, aiding in the interpretation of the accident prediction model. Coming to the next algorithm, which is MLP, multi-layer perceptron. MLP is a type of feed-forward artificial neural network that consists of multiple layers of nodes, neurons, with each layer fully connected to the next one. It's a versatile and powerful algorithm used for both classification and regression tasks. In the context of maritime accident prediction, MLP is utilized to build a predictive model capable of capturing nonlinear relationships between features and the target variable. By adjusting the architecture, number of layers, number of neurons per layer, activation functions, MLP can learn complex patterns from the data and make accurate predictions. It's particularly useful when dealing with high dimensional data or when the relationship between features and the target variable is nonlinear. Comparison graphs offer a visual breakdown of how our models perform across essential evaluation metrics. This bar graph consists of subplots, each representing the accuracy, recall, precision, and FN score of different algorithms. Here on the x axis, we have the algorithm's name, and on the y axis, we have the scores for the respective evaluation metrics. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. Coming to recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. Coming to precision, precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. The algorithm which is performing best in all the evaluation metrics will be used for prediction. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here I am copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are new users, we need to register first, but I have already registered, so click on login link here. Here we need to enter the username and the password which we have registered, and then click on login. We have logged in successfully and we are redirected to the prediction page. Here we need to enter all these parameters. Before entering the parameters, let us understand the parameters. The first parameter is rain. Presence or intensity of rain at the time of maritime accident. Coming to the next one, which is air temperature. Temperature of the surrounding air during the accident. Water temperature. Temperature of the water in which the vessel is operating. Persons on board. Total number of individuals present on the vessel during the accident. Crew members. Individuals responsible for operating and maintaining the vessel. Passengers. Individuals on board the vessel for purposes other than operating it. Longitude, east west position of the maritime accident on Earth's surface. Latitude, north south position of the maritime accident on Earth's surface. Let us enter the parameters. After entering the parameters, the application will predict whether maritime accident has occurred or not. So I'm entering the parameters here. Rain is 1. Air temperature is 285.92. Water temperature is 284.26. Persons on board 3131. Crew members 961. Passengers 2160. Longitude 55.34. Latitude 131.65. So we have entered all the parameters. Now click on submit button. So here we can see we got the result. A ship collision is possible. Let us enter another set of parameters and check whether accident has occurred or not. Click on home link here. So here I'm entering another set of parameters. Rain 0, air temperature 287.03, water temperature 285.93, persons on board is 3362, crew members is 913, passengers is 2449, longitude is 39.26, latitude is 76.59. So I have entered all the parameters. Now click on submit button. So here we can see we got the result. A ship grounding is possible. So here ship collision occurs when vessels physically collide, often due to navigational errors or adverse weather, leading to damage, injuries, and environmental risk. And ship grounding involves a vessel unintentionally running aground or hitting the seabed, typically due to navigation mistakes or equipment failures, resulting in hull damage and potential environmental hazards. In this way, just by entering the parameters, we can predict whether collision or grounding has occurred or not. Now click on sign out link here. The conclusion of the project is the project has successfully developed a predictive system using machine learning techniques to accurately forecast maritime accidents. Through rigorous testing and evaluation, the system demonstrates notable effectiveness in identifying and predicting various types of accidents, including ship collisions, groundings, and soil spills. The developed system holds significant implications for safety and risk management in the maritime industry. By providing early warning systems and actionable insights, stakeholders can proactively mitigate accident risk, improve safety standards, and minimize the environmental impact of maritime accidents. This system represents a valuable tool for enhancing regulatory compliance and ensuring the safety of maritime operations. While the project has achieved substantial success, there remain opportunities for further refinement and improvement. Future research could focus on enhancing the interpretability of the predictive models, incorporating additional data sources for more comprehensive analysis, and exploring advanced machine learning techniques to further enhance predictive accuracy and reliability. Additionally, efforts to address any remaining limitations or challenges encountered during the project will be crucial for the continued development and adoption of the predictive system. The project's contributions to the field of maritime safety and accident prevention are significant. By filling a critical gap in current accident prediction methodologies, the developed system offers a valuable solution for enhancing safety measures and reducing accident rates in the maritime sector. Its adoption by stakeholders, including ship operators, port authorities, regulators, and insurers, stands to make a substantial impact on the overall safety and sustainability of maritime operations.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.